The future value f of an investment p at a nominal rate r compounded n times is a function of time t measured in years, given by the exponential function f of t equals p times 1 plus r over n to the power of n times t. What is the amount that would need to be invested at 3.25% compounded quarterly so that the amount at maturity in 6 years is $25,000? Plugging this information in and solving for p gives us the principal value of $20,587. Now we'll consider another exponential function that models asset appreciation and depreciation. Consider a certain vehicle worth $50,000 that is depreciating in value by 12% over time. A vehicle depreciates continuously, that is, at every moment. It doesn't wait until the end of the month or at the end of the quarter. To model this, we use the function f of t equals p times e to the power of rt. In 2 years, for example, the value of the vehicle is $39,331. So what exactly is the value of E and where does it come from? Well, going back to the formula f of t equals p times 1 plus r over n to the nt, consider this piece. Take r equal to 1 and we'll let m represent the number of compounding periods in a year. Then r over n equals 1 over m, which implies that n equals m times r. If the compounding occurs monthly, for example, then m equals 12. If it were daily, then m would be 365. But remember that assets depreciate or appreciate at every instant, and so we have to let m get larger and larger. In other words, we have the limit as m goes to infinity of 1 plus 1 over m to the power of m times r. By choosing larger and larger values of m, and computing 1 plus 1 over m to the power of m, we can see that we get numbers close to 2.71828. This irrational number is so common in the analysis of natural growth that it has its own special constant, the letter e. This is just like the way pi is a special constant that represents 3.14159 and so on. So f of t equals p times 1 plus r over n to the nt becomes f of t equals p times e to the power of rt when the number of compounding periods becomes infinite. In such models, we say that the value is changing continuously with respect to time.